welcome back from that break. We are continuing with examples about discriminative of quadratic equations. So the question now is here on the board, which is saying that show that the roots of the equation, which is this one, are real if only k is not greater than 3 out of 2. Is not greater than 3 out of 2. And also they say that find the value of k if one root is 6 times the other. So what we do from here, from this, just this statement, they say if only k, like if I try to represent this one, if only k, is not greater, that means it is less. It's not greater than 2. And we also know that for real roots, when they say real, we say it is greater or equal. So when it comes to this one, when they say is real, they say are real if only k is not greater. So for this case, it is supposed to be not greater than the 3 out of 2. So that's what we shall derive to read on this answer, which is not greater. That's what they want us to show. Now they have given us this equation that they are saying that k plus 3 x squared plus 2 into 3 minus k x n plus k minus 1 equals 0. So that's the equation which you have. We know that we say this value is a, this is b, this is c. So we say now, they say that for real, we know for real, we shall see that our b squared is greater or equal to 4ac. So now substituting the values of b, then b and c, b and c, then we shall have that the b, which is 2 into 3 minus k, the whole thing squared, will give us this side that 4 times the value of a, which is k plus 3, then times k minus 1. So that's what we have. So now we are going to deal with this square it, which becomes a 4 into 3 minus k, the whole thing squared, which gives us for this side, then open the bracket. So we have to expand this. So this time this, which is the k squared. So now we are here, this times this, which is negative k plus 3k. Then this time this, which is minus 1. Minus 1. No, it is not minus 1, which is minus 3. So that's what we have. So now we have to square this one, which now becomes, but before we square, we are seeing here we have a 4, and here we have a 4. So this 4 can cancel by dividing both sides by 4, even here by 4, they will go away. So here we shall remain with this one, but when we square it, it will become as 9 minus the value of that one, which is 6k, then plus this one, which is the k squared. So this one will be equal to this value, this side, which is now k squared, this one and this, which will give us something like plus 2k, then minus 3. So that's what we shall have this side and the other side. So we have this one and this one. So what we do, everything which is on the left, we take it the right hand side. So we shall have that when a k goes this way, k squared, it will go to 0. So this one will be 0. So now we take this one also, the other side. So we take this one, the other side, which will be, but what we do, we bring the 6 this side, then we take a 3 the other side. So when we bring the 6 this side, it will come to be with this, the 2. When we add 6 plus a 2, we get that is 8. That becomes 8. And here we are saying that it becomes 8k. So this one will be equal to when we take the 3, the other side, it becomes 9 plus 3, which is a 12. Then divide both sides by, see what, this one is greater or equal. Then here it is greater or equal. So now here it will be greater or equal to that. So that is what we have. So for this case, it has to be now, it is divide both sides by 8, then here by 8. So k, and then it becomes greater or equal to this side, it is 12. When you divide both sides, we have to reduce this one, which becomes by 2 here. So we can use 4 by 4, which is a 2, and by 4 here it becomes a 3. So it becomes 3 out of 2. But they say that we have to show that the roots of the equation are real, and if for that and they are greater than the 3 out of 2. So for this case, what you're going to do, by doing this one here, for us to show that they are not greater, what we do, we just change the sign, which we say that means our k, therefore it is less than. So if they are not greater than this, that means they are less than something, which is this one, which is 3 out of 2, as what they say. So not greater, that means this one must be negative. So that means everything which is less than this or less than this, that means it's greater than this. So which is greater than this is less than this. So that's what they wanted us to just show. So also a question was continuing that find the value of k if one root is 6 times the other. So after showing this, so we are going to the next step of the question. So this is the same question which we are considering. So we say that when we are dealing with this thing that one root is 3 times or 6 times, what we do, we first make this one to become a degree of 1 by dividing both sides by this. So it becomes divided by k plus 3. Even here k plus 3, then here k plus 3. So that's what we shall have. Yes, so that can remain with a degree of 1, so it becomes x squared plus 2 into 3 minus k out of k plus 3. Then plus, this one is x, then plus k minus 1 out of k plus 3 equals 0. Then they say that for if one root, so I say now let one root be 1. Let one root be alpha, so the other one will be what? and the second be what? Be beta. So if one rate is alpha, the second one is beta. So for that case, for one root, for alpha to be 6 times the other, so it will be alpha equals 6 beta, and also the beta equals 6 alpha. So that's what we are dealing with. For alpha must be 6 beta and the beta must be 6 alpha. That is one root to beta 6 times the other. So now we have to get now the sum and the product, because we have to get the value of k for that scenario. So for that case, getting the equation or the value of k, for that we have to get the sum and the product for that. So for this case, having this one and this, we said we first bring this one this side and this one taking the other side. So here our alpha will be equal to, so I take this one, which is minus 6 beta equals 0. Even here beta minus 6 alpha equals 0. So everything is equal to 0. So what we do, we say that when everything is equal to 0, what we do, we multiply the 2 and we equate to what? To 0. So, but also before multiplying it by 2, we have to get the sum and the product in alpha and beta. So that means our alpha plus beta, which is the sum, will be equal to, we said the whole of this thing. You also consider the sign. When it is negative, we write as a positive, and when it is a positive, write it as a negative. So it is negative 2 into 3 minus k out of k plus 3. So here now alpha beta, it becomes as k minus 1 out of k plus 3. So that's what we have out of that. So now we are going to now continue with what we have here. We said when everything is equal to 0, we just multiply and equate to 0, which is alpha minus 6 beta, then times beta minus 6 alpha. So this one will give us a 0. So that's what I was generally talking about. Everything you equate it to 0. So for this case, this times this becomes alpha beta. So this times this, which is minus 6 alpha squared. So this time this minus 6 beta squared. This time this, that is plus 36 alpha beta, which gives us a 0. So now we have this and this. What we do, we added the 2, this and this, which becomes now 37 alpha beta. So now we are here now, this one and this one, which is, we factorize out the common, which is minus, this one becomes 6 into alpha squared plus a beta squared equals a 0. But also we saw that in the other scenario that we can also deal with this. We see how we can try to expand it so that we can come out with the desired value for this. So this case, we said that when we are expanding alpha plus beta squared, this one is just simple by saying which number can we expand so that we can get alpha squared minus plus beta squared. So we saw that the other time it was alpha plus beta, then the whole thing squared, so that this one we shall get alpha squared plus beta squared. Then here it becomes plus 2 alpha beta. So that when I take this one, this side will remain with this. So for that case, I'll have that alpha squared plus beta squared, which will give us alpha plus beta, the whole thing squared minus 2 alpha beta. So that's what we shall have by now substituting in this one. We shall have that 3, that is 37 alpha beta minus 6 into alpha plus beta, the whole thing squared minus 2 alpha beta. So this one will give us a 0. So we have this one. So what we do, we multiply inside the bracket the 6, but which is a negative. So here it becomes negative, that is 37 alpha beta, so minus 6 into alpha plus beta, the whole thing squared. So this minus this, which it becomes plus a 12 alpha beta, so which is equal to 0. So now combine this one with this. So we are combining the two, this one and this one, which will be that is 49. So it becomes 49. So we have a 49 alpha beta. So 49. So this side now, when we have this one, that is minus 6 into alpha plus beta, but the whole thing squared equals 0. So now when we reach on this step, now we have substituting the values of alpha beta and alpha plus beta. So that's why we are going to go. So we are substituting in the values. That is now becomes here 49 into the value of alpha beta, which is k minus 1 out of k plus 3. So this one minus, here it becomes a 6. 6. So times the value of alpha plus beta by the whole thing square, which is a negative 2, into 3 minus k out of k plus 3, which is a square. So now we said a square of a negative is a positive. So now we have to do what we have to do. We have to apply a square on each of these. We apply square on these ones. So here it becomes now 49 into k minus 1 out of k plus 3. So minus. So here when you square this one to become now to be a 4. So 4 times a 6, which will become now 24. 24, then here in the bracket we remain with the 3 minus k, the whole thing squared out of k plus 3 squared, so which gives us a 0. So what we do, let us take the negative 24, everything which is here, this side. So by taking this side to come to a positive, so it becomes like now when I try to multiply the 49 here, we have 49 k minus 49 out of k plus 3. So this one gives us, by taking everything this side, I have that will be 24. So here we try to okay, first leave it like that, which is 3 minus k squared out of k plus 3, the whole thing squared. So since we have here k plus 3 k and the k plus 3 squared, what we do, we multiply both sides by a k plus 3 squared. So when we multiply this one by k plus 3 squared, here times the. So we are multiplying times k plus 3 squared, even this side times k plus 3 squared. To find that this one will go away. We shall remain now, when we divide this by this, we remain with 1k plus 3. So now here it becomes 49k minus 49, then times k plus 3 equals, now this side becomes 24 to 3 minus k, the whole thing squared. So that's what we have there. So we are continuing. This one don't need it. So now we have to open out those brackets. So it is this one times this, which will become to be 49k squared. So now again that one times this, which becomes that is 98 plus 49. So this one becomes to be a 7, get, that is 147. That means it's minus, it is plus 147k. So now we are this one times this, that is minus 49k. So now it is this one times that 49, and see that is minus 147. So now this one gives us now this one 24 into. So you have also to expand this one, but it will first leave it. That is k. The whole thing squared. So for this case, I try to decompose it by reducing it. This one becomes now 49k squared. So this one and this one, which will give me, that is 147 minus 49. So this one becomes now 98. So now it becomes plus 98k. So now we are this side, which is minus 147. So equals 24 into, we have to expand this one, that is 9 plus, so 9 minus 6k, then plus a k squared. So now this one becomes, opening the brackets, so here we have 49k squared plus 98k minus 147 equals 24 times 9. Like now when I multiply 24 times 9, I have 216, then minus 24 times 6 times 6, which is minus 144k, then plus 24k squared. So that will be our expansion. So now from here, we have to take everything which is on the right, we take it to the left hand side. So for that case, to be this one minus 49 minus 24, so which will give us 25k squared. So it is 25k squared. So we take also this one, the other side. So it will be 144 plus 98. So 144 plus 98. This one becomes plus 242. 242. Okay, so also take the 216 the other side, that is 216 plus 147, so it becomes minus 363, so it must be equal to 0. So since this thing is too huge, what we do, introduce now the other equation or formula after getting the completing squares, which will be negative b plus or minus root of b squared minus 4ac out of 2a. So that is what we have. We are going to substitute the values of a, b, and c. So here it will become now our k equals to, that is the negative 242 plus or minus root of b squared, which is 242 squared minus 4 into the 25, then times negative 363, then all over 2 times 25. So for this case, we shall have the K1 and K2. So now they must be 2. Now for this case, our K1 will be K1 will be 33 out of 25, and also K2 will be, this is 25, then you get 242, then negative 363. So the K1 is 33 point, that is 33 out of 25, then K2, it becomes a negative. K2 is negative 11. So those are the answers which we shall get after dealing with this equation. So with that, by the end of this, that one comes to the end of this example. So next time we shall begin on the other side. Just first have a commercial break.